every gemstone has its own refractive index. This is my little sheet that I memorised. It's got 160 of our common gems in it with all of the refractive indexes against them. For example, we can have a look at quartz. Quartz refractive index is 1.553 to 1.544. Now it's the only gem in the world that has that refractive index, so it's like a unique identifier to that one gem. To measure that refractive index, we have a tool called the refractometer. This is my one from the GIA. We have a little eyepiece. And I'll go through and show you how to use that in a second and how it actually works. So what is refractive index? It's pretty much when light travels from one medium to another, it slows down and it bends. We've all seen that when we put a straw into a glass of water. It looks like the straw bends when it's inside the water. It's because the light's getting slowed down effectively. So what happens with refractive index is that there's a point where when light travels from one medium to another, that light, instead of entering the medium and slowing down, actually hits the medium and bounces off. That's called the critical angle. So it's when you turn from light being refractive, entering the gem, to light being reflective and bouncing off the gem. Now all the refractometer does is measure that angle and give us a number. So on the side of my refractometer here, there's a list of all the common gems, not as many as my list, but there's a lot there. And if we have a look at the refractometer, what we see is a little plate where we put our gems on here. This section is called the hemicylinder, so it's pretty much just a piece of glass that the light travels through, hits the gem, and then the refractive index can be measured. So if I put a gem on there, like here I've got just a nice little amethyst. So when you're actually using the tool, that's what it looks like. There's the amethyst sitting on top of the hemicylinder, and we look through the eyepiece and we can measure the refractive index. So let's go away and I'll actually show you what it looks like when we read refractive index for a gem. Here we are, all set up with our refractometer ready to go. We've got a citrine gemstone here, which is part of the quartz family. So we're going to test that and see if we can read the refractive index. Got our refractometer. I mentioned to you before the hemicylinder. Over here we've got a polarizing lens. So if you remember back to difference between a singly refractive and doubly refractive gemstone, the polarizing lens will give us the minimum and the maximum refractive index of a doubly refractive gem. So when you have a singly refractive gem, you get one single RI reading. When you have a doubly refractive gem, you get 2 RI readings. We've also got refractometer liquid. So this is special liquid that we place on top of the hemicylinder, between the hemicylinder and the gemstone. It itself has a refractive index of 1.81, so any gem that's over 1.81 we can't actually test. That's what we call an over the limit gem. And we use other techniques to figure out what those gems are. And on the back of the refractometer we have a monochromatic light. So it's just a light source that's pumping out one single wavelength of light, which makes the reading on the refractometer a lot sharper. Okay, so to start with, we'll put a little bit of RI liquid at the back of the refractometer, grab our stone, and then we can slide that on. There we go. Slide that onto the hemicylinder. Now if we zoom in here, we'll make sure that the stone is on the you can see a line there. It's not very clear. There, that's better. So you can see a line there between 1.54, 1.55. So it's sitting somewhere in between where we want it. The quartz has a refractive index of 1.553 to 1.544. So now what we do is we grab our polarizing disc lens, put that over the top, zoom back in again. So we can see when we turn the filter, you can see it jump up there to 1.54, and then turn the filter 90 degrees and it goes down to 1.55. 1.54, 1.55. And that's enough evidence to tell us that this is in the quartz family of gems. And in the quartz family, we'll just wipe it down because we don't want to scratch the hemicylinder. And in the quartz family, an orange version of that quartz we call citrine. Another interesting note with gems is that the harder that gemstones get, generally the higher the refractive index they'll have. So if you think about maybe some gems that you have at home, like fluorite, fluorite has an RI of 1.4. It's fairly low, it's a fairly soft stone. Then you think about the other scale, you've got stuff like corundum, you've got sapphire and ruby, 1.76, 1.77 RI, and then you've got diamond, which is the hardest gemstone, which has an RI of 2.41. So what you can do at home is have a look at your stones and tilt them and get them to reflect light off the top of the gems and have a look how different they look. So when you get a diamond, it's what they call a adamantine luster. It's very, very mirror-like. Whereas if you go and get something like a piece of glass or an opal or fluorite and you have a look at the way the light reflects off those gems, they're not as shiny as a diamond. They're not as shiny as a corundum. So that's something that you can go away and have a bit of a play with. I hope you've enjoyed this little video. If you have any questions, put them down below